This is the Algebra 3 Fall Semester Exam Review. This is part 1 of 3 parts. The review is 6 pages, and each part will do 2 pages. Okay, so we start off with algebraic properties: commutative property, associative property, distributive property, multiplicative identity, and additive identity. Identities mean that when you're done, you end up with the same thing you start with. So multiplicative identity, you multiply anything by a 1, you get itself back. So 5 times 1 is 5. So this is an example of multiplicative identity. The other identity is you can add 0 to anything. 2 plus 0 is 2. So that's the added identity. Okay. Another easy one is distributive property. Everybody knows this. 4 times the quantity, 2 plus 1 equals 4 times 2 plus 4 times 1. Okay, so that's the distributive property. The other two that get people confused are the commutative property and the associative property. Okay, so let's look at this. They typically, the associative property typically has parentheses and the commutative property doesn't, but that doesn't mean that they can't have parentheses. So look at this. Here we're multiplying. 6 times 9 equals 9 times 6. The order is different. Order doesn't matter. So that is a commutative property. Community, you can move around in a community. And the associative property means that, look, the numbers are the same, but what is moving is the parentheses. Okay. So order of operations, you're adding 4 plus 3 first, that's 7, plus 5 is 12, whereas 4 plus 5 is 9, 9 plus 3 is 12. Okay. All right. The next ones are simplify. It doesn't say evaluate, it means simplify. So simplifying, and you should have the properties written down in your notes somewhere. You can get them off the last quiz we took. But this is, how do we combine these exponents where they're the same base? Well, we end up adding them together. All right, where here we're doing the exact same thing. We got a 5 out here. That is by itself. There's no exponent working on it, but we have 3 x's and 7 x's. That's a total of 10 x's. So x, 3 plus 7 is 10. Third one is we have a negative exponent. Negative exponent means move it from one side of the fraction to the other. So here we have 3 times x to the negative 2. That moves from the top of the fraction down to the bottom of the fraction. We have still x squared. The difference between this 2 and this 2 is this has a minus sign, this does not have a minus sign. Number 9 is similar. The negative sign here with the 5 and a negative 3, this moves this down to the bottom, this moves this up to the top. Now we can look at it. The way I like to look at it, we could use other properties now where we subtract these, but it's the easiest way to look at it. Do you have more x's on the top or on the bottom? Well, obviously you have more than the bottom. How more on the bottom? You have 2. For these problems, 6, 7, we ended up adding the exponents because you're multiplying. This is a power rule. This is a power of a power. This is actually equivalent to x to the 7 cubed is x to the 7 times x to the 7 times x to the 7. You have 7 plus 7 plus 7, that's 21. Or you're multiplying 3 times 7 is 21. Then we have number 11. This one's a little more complicated. You could do this many different ways, but the easiest way might be to attack which inside the parentheses first. Do you have more x's on the top and the bottom? You got 6 on the top and 3 on the bottom. Well, that means you got, well, no, I did this differently. So we'll first talk about how I worked it out here. We took this negative exponent. This flipped this fraction in here. So 6 on the top over 3 with a negative 2 exponent. We flipped it from 3 over 6. Okay, and then we simplified what was inside the parentheses. You have more x's on the bottom, 3 more on the bottom, and then we're squaring it. So it's 3 times 2 is 6. But I could work this a totally different way. I can take this, and first I got x to 6 over x cubed to the negative 2, and first say, well, we just got more x's on the top, 3 more on the top, and multiply it by negative 2. Now multiply that, we now have x to the negative 6. The negative means move, so that's 1 over x to the 6. Okay. Don't know where it started talking. So describe each set using interval notation. A bubble means not include in a number line. A dot means included in interval notation. A parentheses, this is a negative 3. Parentheses is a not include. Okay, so that is a not. And this is the square bracket. It does include the value. So this is the set of numbers from a negative 3, not including a negative 3, to 5, including the 5. So the square bracket means inclusive. Okay. Here we have an arrow going off forever and to the left. That's negative infinity. Negative infinity is always at the beginning. Whenever it exists, it always exists in the beginning. You can only have positive infinity at the end. So this is negative infinity up and 2, but not including 2. So there's a bubble 2 and a parentheses here. Here we have a gap. We're starting at negative infinity and we come up to 3. We don't equal 3, so we have a parentheses. And also, good point is, by definition, the infinities, by definition, you can never get there. So infinities always have parentheses next to them. Remember, the parentheses are curvy. Parentheses are curvy. Okay, so negative infinity to a negative 3, parentheses, because not include. Union, U to include. Anytime you have multiple, you just stick a U in between. Then we're going to start off with an include 5, which is a square bracket, on to infinity. And here's one where it starts at the right at a negative 6. It's a dot, so it's a square bracket. Negative 6, comma, to infinity. It means negative 6, including 6, on forever this way. Okay. Okay, we just did these in class on the last test review. Okay, this is increasing and decreasing. It's not growth and decay. Okay, so plug this function into y equals in your calculator, and you will see that this is a decreasing function. Well, this one is also a decreasing function. This one will be increasing, and this one will be increasing. That's all you're looking for. As you're going from left to right, is it dropping, or going left to right, is it increasing? That's increasing and decreasing. Okay, moving on to page 2. We start off with some examples of parent functions. Here we have a linear. Okay, linear is a straight line. That's this graph right here. And the equation for a linear, the parent function, is y equals x. Absolute value, that's the v. Okay, so the equation for absolute value, this is where you have the goalpost. Remember, for absolute value in a calculator, it is math num 1 : ABS, and you're going to get the goalposts if you're using one of the good calculators. If you use the old TI-83, you're going to get an ABS and not the goalposts. Okay, so where are we at? Absolute value. Absolute value is D. Oh, absolute value parent function is D. That's the absolute value, and its graph is I. This is the graph. Okay, quadratic. Quadratic is the U-shaped parabola. Okay, the equation is y equals x squared, and this is f. That's the graph. For square root, that is C, the square root symbol, and we have, this is the graph right here, J. An exponential, this is an exponential growth. This is 2 to the x, this is exponential growth, and this is the increasing function. Okay. Beginning of the year, we talked about, is it a function or not? And the best, if it's in a graph form, the best way to test it is the vertical line test, which means if you draw a vertical line and it touches more than once, and here it touches twice, it only has to do it at one spot, this is not a function. Okay, when it's, you could graph these points and you'll see that none of them stack up vertically. But a poor man's definition is the x's do not repeat, okay? But you need to ask yourself, if I added another point to this and I added 0, 3 again, well, that is the exact same point. So graph it, they're overlap it, that you don't even look to see it. So first delete any duplicates and then do the x's repeat. After removing any duplicates, if x's repeat, it's not a function. If the x's are all unique, yes, it is a function. And then for 27, that is a sine function. And anywhere we draw a vertical line, it crosses only once. That means yes. It is a function. Okay. Moving on to these. Now this is where a calculator is really going to help. Okay. We look at 26, the domain. Okay. We look at 28, 29, and 30. Absolute value, the domain is continuous. There's no reason that we need to restrict the x's. We can plug in any x and get a y out. The same thing here. Okay, the only two functions that restrict the function are square root. Square root of x must be greater than or equal to 0. Okay? Well, how do we determine that? Excuse me. Well, we look at this function and look what's inside the radical. That's the radicand, okay? That is x plus 3 must be greater than or equal to 0. Okay? So subtract 3 from both sides, and we get x must be greater than or equal to a negative 3. And it can be equal, so we have a square bracket, and it goes on to infinity. Now, the range, we should graph this. And if we graph number 28, it's going to look like this. In the graph, it starts here and goes up. Well, what is this point right here? This point right there is a negative 3, 1. That's its starting point. So that's where the domain is left to right. So it starts at a negative 3 and goes to the right, which is positive infinity, and the range It's a bottom of 1, positive 1, and goes on up to infinity. Now the minimum or maximum, this is a min, and the minimum is right here, this negative 3, 1. It is increasing. This is always increasing, forever and ever it's increasing. So it starts at the beginning, and the beginning is the negative 3, 1. So we're describing the x's. Okay, so it's increasing, and it looks like this is wrong. This value should be right here. This is a negative 3 on to infinity. Decreasing, well, it's never increasing. It's always increasing. It never crosses the x-axis, so it doesn't have any zeros. It is positive forever from, again, the negative 3 to infinity, so this increasing and positive should be the same, and it's never negative. Okay? Okay, number 29. 29 is the absolute value. So we do a graph for 29, and I can see that this moves 2 to the right. So we're going to move 2 to the right and 5 up. 1, 2, 3, 4, 5. And that's the vertex, if you will. And it is reflected. So this thing is going to go down like this. All right? The range, well, these go on forever. So negative infinity is the bottom. The top is 5, so that's the top, and it equals this. So we have a square bracket here. Okay, the maximum, this is also the top. This is the max. It is a max at kind of covering it up here. Let's see if I can erase it now. Nope, can't erase it now. Max is at 2, 5. All right, it's increasing from, I'm going to do this in blue, from negative infinity up to the x value of 2. So that's what it's doing there. And I put parentheses there because at 2 it switches from increasing to decreasing. So at 2 it's neither increasing nor decreasing. And we'll put decreasing in red. And this is, well, we put it in black to make it a different color. This is where it is decreasing, and it's decreasing forever. Excuse me, it's decreasing from the value of 2 on to infinity, so that's where it's in decreasing. We have zeros. Okay, so we've got a 0 right here, and we've got a 0 right here. All right. Now, this is where the function these are also x-intercepts. It's at a negative 3, 0. This is a negative 3, 0, so my graph's not totally accurate. This is supposed to cross the x-axis at a negative 3, and this is where it crosses the x-axis at 7. Okay, where is it positive? All right, now positive, we're going to have here everything right here. This is where it is all positive. I'm shading it in, but it's really just the outline. So from this 0 to this 0, so from a negative 3, 0, and 7, 0, these are coordinates. And it's positive from this negative 3 to 7, and then it's negative down here, that's negative, and that's negative, from negative infinity up into negative 3, and from 7 to infinity. Okay, let's just move this over and work on this side. This one is a quadratic. Okay, so if I were to graph this one, I have it's moved 1 to the left and 4 down. Okay, so this is where the vertex is at a -1, 4. You can see that in the graph. All I need to see, I need to see these values over here on this. Okay, so I needed to see this values. That's why I shrunk it. Okay, so it is, the domain is -infinity to positive infinity. There's no gaps in there. The range is, so this is going to be, let's use these numbers here. It's minimum at a -1, -4. It's increasing. The zeros, okay, let's graph the zeros. The zeros are at a -3, so that's 1, 2, 3. So that's one of the zeros right there. And the other 0, it says, is at 1, 0. Okay, so come back here and put 1 tick mark there, and we got a 0 there. Didn't ask us for the y-intercept, but this is a parabola that's going to open upwards. Okay, now, so let's go. Range is bottom to top. So tap the blue points to display hints. Really, don't give me hints now. I'm just learning how to use this tool, so bear with me. Okay, so we've done domain, we've done the range. This is the bottom. The bottom is the y value of, oops, that's a -4. This is supposed to be a -4 right here. -4, -1, -4. Yes, indeed. There's another mistake here. Okay, yeah, don't give me that. Pen, red, the vertex, this range, this is supposed to be a -4 to infinity. Okay. Okay. We make mistakes. Okay. The minimum is a -1, -4. That's the vertex. It's the bottom. That's the minimum. It is decreasing from -infinity. So it's decreasing from the left till it hits the vertex. And then that's the inflection point. And it's increasing from this vertex up this way. So increasing from a -1 up here, it is decreasing from -infinity to here. Now, where are the zeros? We already graphed the zeros. So -3 and 1, those were here. Now, where is it positive? I need more colors. Okay, green, good. Do we have green now? Good. We got green. So we're going to use green for positive. So it's from here out here. Up into, I'm going to put a bubble there, and I'm going to put a bubble there, and that is increasing. So it's 2 spots. There's a left-hand part and a right-hand part. And what can we use for negative? Yellow. Okay, good. This is another bubble here and another bubble here, and this is where it is negative, from a -3 to here. Okay, so this is part 1 and ending.